Hi Tanisha, how are you? Well, Hi guys. Before I get started, right? Before I discuss homework, right? Meaning to what level you all know combinatorics probability, guys? Meaning I just want to have a feel of what each of you know. I know Dia, what you know, I know. Mitra, have you dived into combinatorics before?
No, auntie.
Do you know about the Pascal's triangle? Not really. Combinations, permutations? Not really.
I think I know a little bit about permutations and combinations.
Okay, I see. Not into binomial expansion or anything.
Yeah, I do binomials, polynomials.
You do binomials now, but have you come across binomial expansion? What is the coefficient of x plus y power of 28? No, not really.
The coefficient, wouldn't it be 1?
Uh-huh.
No,
Uh-huh.
I
You'll have to sit and compute. It's a big one, big problem. Okay. No, I just want to know where you are. Okay. Dependent probability, independent probability, have you come across? You have? Okay. I see. Oh, dependent you would have come across in seventh grade, right? I see. Okay, how about you, Arna? No, okay. Vishrang, how about you?
I know a little bit about permutations and combinations, but like not anything else.
Not anything. Okay. Ashi, how about you? Not really. Okay, no problem. Okay, we're going to continue with geometry. Okay, that's the plan. So let's go ahead. What did we end with last week? Let's see. One second, guys. Okay. Are you able to see my screen? Let me first check. You're able to see my screen? Let me directly continue with whatever I wanted to. So last week we discussed triangles, correct? We did not do quadrilaterals. We did some circles, but not all. So this week I want to cover a lot of quadrilaterals and circles, whatever pieces we left. I want to cover congruent and similarity. Have you come across congruent triangles and similar triangles, any of you? You've come across, ma? What do you know, Tanisha?
I know triangle congruence properties, triangle similarity properties, most of those.
Triangle congruence and then what, ma?
Triangle similarity, like the couple of them prove triangle similarity. And then I can prove that triangles are congruent.
Okay. Okay, how about this? Let's go ahead with this one. We'll start with, see, you know, area of triangle, area of rectangle, area of square, all this you know, right? So let's try this one. How about this? Oh wow, what's going on? Something is not right. 1 second, guys. What is going on? Oh, wow. You're going to give me a minute, guys. Something is not right for me. Mm-hmm. Okay, for some reason. One second, guys. I'm going to close and open. Ah, okay. Oh, that's better. I don't even know what is going on. Okay. Let's see. Let me reshare. Okay. I'm just going ahead, Ashi. Wherever I left on, I'm just going to go ahead. Okay. So we discussed last week, we have discussed part 2 of geometry. The previous week, we discussed part 1 of geometry. Okay. I'm still continuing geometry. Okay. So let's go ahead. This is basically a square rectangle based problem. However, before you dive into this, right, I just want to know whether you know what is a plus b the whole square. This is algebra. Okay, without this, you can't solve this. What is a plus b the whole square? Do you all know? Yeah, go ahead, Mamitra.
A squared plus 2ab plus b squared.
Yeah. So how do you do that? A is a number, b is a number. A, this is b. Okay. Similarly, A is longer, B is shorter. Okay. A plus B the whole square. How box method that you learned in elementary. This is A square. This time this is B square. When you multiply this, this becomes AB. This becomes AB. So it is A square plus B square plus 2AB. This is from your algebra 1. Yes, go ahead, Arna.
I don't know if it's just my screen, but I can't see what you're writing.
Others.
I also can't see.
I can't
see
either.
it either.
Wow. Okay. I'll do once, otherwise I'll log off quickly and log in. Do you see? Do you see the board? Do you see my writing?
No.
Okay, guys, you're going to hold on. Okay, you're just going to hold on. Okay, yeah, sometimes this happens with Zoom and I'll have to log off and log in. Hold on. I'm glad you brought it up. Uh, I'm going to leave, come back. You're able to see the board now, I'm assuming. How about this? You're able to see it? Yes, this happens sometimes. So a large square region. So basically what we were discussing, a plus b the whole square formula we were discussing. We drew a square. This was a, this was b. The square is of length a plus b. So similarly, this side will also be cut out as a. Sresht, have you come across this?
Yes, I have.
Okay, a square plus b square.
Yes.
AB, AB. So this becomes a square plus b square plus 2ab. Ashi, are you following Ashi? Okay. Now, a minus b the whole square formula is what? Yes, Matanisha.
A square minus 2ab plus b square.
A square minus 2ab plus b square. Great. Okay, Srish, have you come across this?
Yes, I have.
What is it?
It's it's the difference of it.
Yep, difference of it. So it's the difference of squares, right? So it is a plus b times a minus b. Guys, these three, even in your sleep, you have to come up and say, hey, I know this. You see, three are quite important algebra based formulas which will be used everywhere. Okay, so let's go ahead. Let's try this one. A large square region. I can show you a diagram for this one. If you need a diagram, I can show you a diagram for this one. So if it is a 3 by 3 rectangle, let's say if it is a 3 by 3, here you see, if n is equal to 3, then this region has 9 squares. Okay. Each square has a side length of s and the margin is of distance d. Okay. With this in place, go through this. Let me know what you each of you think before I do the problem. See, every time I do, there's no point, right? Meaning you will never get it. So why don't you try and let me know what you understand, and then I'll go ahead. Vishrank, your thoughts, Vishrank. Vishrank, do you know the algebra formulas that we discussed?
Yeah.
Okay, good. Yes, ma. Go ahead. So what it says, the number of grays, if I consider n is equal to 3, the number of gray tiles would be 9. If n is equal to 4, number of gray tiles would be 16. They are saying if n is equal to 24, number of gray tiles would be 576. Now, okay, considering D as the border, D is the border, okay, here. And the side of the square is S. Side of the square is S. Considering this being the case, you have to find now, if n is equal to 24, they've said that the number of gray tiles would be 576. They're asking for the ratio of D by S. I'll wait for you to think. I want one or two of you to come up with ideas. It's not like everything is given to you on a plate, right? Then you'll never be able to solve. Yeah. Whatever thoughts you have, you can raise, no problem. How do you think we can solve? This does not use any other big formulas or anything, but just that you need to understand and put it into an equation. Okay. If you need help, message as well. Based on that, I'll immediately put it out on the board. Let's not waste too much time as well. Go ahead. Any thoughts, guys? Hey, I want one or two of you to talk. It's not like a class where I keep on talking, giving lectures, and you go. No. Anything incorrect as well is fine, right? And the more time you take, we are going to do only one or two problems, right? I really don't want that. Just talk it out and let's see. Okay. Sresht, I got your message. Like that, talk it out, guys. You can chat. Ashi, the way class works is there is a chat window, ma. Do you know how to chat? Okay, so you can chat with me anytime. Think about this, guys. There is something given 64% of the area of the large square region. Yeah, the borders occupy 36%. That's true. Nice thought. Okay, so what equation can I make? What equation can I make? Tanisha, any thoughts?
No.
Okay, let me go ahead and solve. Okay, there's a big thing given, right? Say this, how many ever number of squares I draw, right? N, irrespective of n's value, this, if n is equal to 24, particularly they've literally given n is equal to 24, it's going to contain 576 tiles, okay? And that is going to cover 64% of the total area. How to find the total area of the region? When n is equal to 24, how many of these borders will be there? Let's see. When n is equal to 3, how many borders are there? N is equal to 3. Yeah, 4 borders are there. Good. So, when n is equal to 24, there will be 25 borders. Are you all with me? So, if I say
Yes.
that as d, 25 times d would be the length of the borders, correct? Okay. Now, but I need to, there will be 24 times s occupying the length of the tiles, right? Does it make sense? So that gives you the whole length. Am I making sense? Now, how to find out the area of this square region? The whole square, right? Right?
Yes.
Okay. So that will be the whole square region. Of that, 64% is what? 64% of the whole square region area will be equal to what? Can you complete this equation? Will be equal to what? I want, please, Riya, tell me what it will be equal to. 64% of the total square region area will be equal to what? Will be the area occupied by 576 tiles. So how am I going to do that? What this side will contain what? Yes,
Is it
Mitra. Go ahead.
is it the tiles?
It's correct. Very good. How will you write it down? It is the area of the tiles. Very nice. Mitra, did you have something?
In this scenario, it'd be equals 576.
576?
Yeah.
What is the area of each tile? 576?
No.
See, ma'am. 576 great tiles. Each tile is of width, yes, right? Do you see it? Yes, Suresh, go ahead.
Would it be 24?
There will be 576 tiles like that. I need to calculate the area of all the 576 tiles. That is only 64% of the total square, right? So what would happen? What would come here? 5, am I clear, guys? 576 times s square, right? Did I make sense? Okay, now 25d plus 24s, the whole square. What is 64 by 100? Any fraction, if it is simplifiable, I will have to simplify.
It's 16 over 25.
Yep, will be equal to 576 times a square. But when you think about this, everything is a square on both sides of the equation. Did you see that? Everything is a square. So this becomes 25d plus 24s times 4 by 5 equal to 24s. Am I making sense? Did that make sense?
Yes.
Yep. I would like you to complete and let me know the answer for this one. If you didn't understand, you have to tell me. Go ahead. Are you able to do?
Ma'am, is it 4D equals S?
D by S निकालना है.
It should be, see, okay. It should be a ratio of two variables, right? You cannot get yes separately, right? It should be a ratio, correct?
So would it be 1/4 for the ratio?
1/4 for the ratio. Is it so? I don't think so. Let us see. So here, when I do this, when I see 4/5, right? I can take it up, bring it down, 5/4, 25D plus 24S divide by 24S, right? Will be equal to 5/4. Now, wait, I'll have to close off the videos. Now, how do I solve this? Let me go ahead and solve and show. 25D plus 24S divide by 24S. So I can make this as, hold on, from here it's easy. I think this is one of an old MCAT problem. So 25D by 24S plus 24S divide by 24S equal to 5/4. Now this becomes 1. So 25D by 24S will be equal to 5/4 minus 1. Now this is 1/4. 25D by 24S will be equal to 1/4. Now multiply by 24 by 25 on both sides. They'll get cancelled. 24 by 25 on both sides will be D by S equal to 6/25. Any questions, guys?
No.
Hashi, are you able to follow, ma? How about Dia? Are you able to follow?
Yeah.
Shehreen, how about you? Okay, coming to Sresht. You will not get a single variable value, right, Sresht? Did you get it? It's always D and S. So we are also asking for the ratio of D and S. It cannot be
A single
a
variable.
single variable. You got it? Okay, let's move on. Okay, this was a difficult problem, but this was one of old, I think so. It was an AMC8 problem, if I'm right. Okay, coming to a rhombus, right, guys? Given the diagonals, do you all know what is the area of a rhombus given the diagonals? Rhombus, if you're given the diagonals, do you know the area of a rhombus? Let's say this is D1, this is D2. What is the area of a rhombus? Okay, If you want, you can note it down. Okay, this comes up in competitive math a lot. What is the perimeter, guys? What is the perimeter of this rhombus? You know, rhombus is special, right? What is the perimeter of this rhombus? Okay, I'll show you. Let's say you have this. You know, this is d1 by 2. This is d2 by 2. Okay, so with that in place, right? So what will this be? Anybody please, guys? This is easy. What is this?
Hypotenuse.
It's a hypotenuse.
That's the hypotenuse. So what you can apply to find that?
The Pythagorean theorem.
Nice. So the whole square plus d2 by 2, the whole square. So if you think about it, the square root of that is that, right? But however, you have 4 of that, meaning when you think about it, you have 4 of this. 4 of this means this side, this side, this, and this side. Everything is that, right? So I'll write out 4 times d1 square plus d2 square divided by 4, right? If I have it that way, then it is, what happens? 4 times 1 by 2. You know how to work with radicals, right? Meaning this 1 by 4, when it comes outside, it becomes 1 by 2. So this will be d1 square plus d2 square. That gets you to 2 times d1 square plus d2 square. Any questions? Any questions? So that is the
Can you
perimeter
write-
of the...
Can you write it higher? Because I think I missed a little bit. Like
What did you miss, ma?
I think part of it is off the screen for me.
Oh, really? Okay, okay. Okay, I hear you. I hear you. Is there a possibility for you to enlarge your screen? I'm just asking. It's not like you should do it right off. Tanisha, the 348 was incorrect. Did you check, ma?
Yeah, I did. I
You
figured.
forgot to take the square root, I think, right?
Yeah, I did.
Okay. So let me rewrite it. Okay, if you're not able to see
I can
this.
see it now. It's fine.
Oh, you can. Okay. So
Yeah.
did you enlarge it? What did you do so that I can help others too? What did you do?
I just adjusted the screen a little bit.
Oh, I see. You're able to see the rhombus and all?
Yeah.
Okay. From this, the takeaway is for a rhombus, given the diagonals, you should know the area and perimeter. That's all. If you didn't understand, you have to raise up now. Can I move on? Can I move on? See, my plan is to cover one more week of geometry, then go to combinatorics probability. Okay, combinatorics probability will achieve a level where we can understand at least the basic probability combinatorics problems. Okay, that is the plan, but let's see. Can I move on? Because
Yeah.
this week, if we cover quadrilaterals, circular areas, what we have not covered, and then what did I say? Congruent triangles and similar triangles, we can do complex shapes next week. Let's see. Okay. Now, what did I want to do? You all know the area of a parallelogram, right, guys? Do you all know the area of a parallelogram? Let's say L, this is B. What is the area of this parallelogram? Guys, that you know, right?
L times B.
Yeah, thank you.
times
L
B.
times B. Okay. Now, what do you do? How did you get that? Usually what I do, I'll take away this triangle, right? I want to make it into a rectangle. How did you get that? You need to understand. Then only it's all easy. Now, if you take away this triangle, right? Put it in here, meaning I take the triangle away. I add the triangle here. See, you see it becomes a rectangle. See, it becomes a rectangle. This is why the area of the parallelogram is L times B. Any questions? Any questions, guys? Okay. Now, coming to a trapezoid, right? You know, if I ask you what is the area of a trapezoid, you all know. What is the area of a trapezoid? Let's say B1, B2, what else I need? H. So what is the area of the trapezoid?
1/2 times B1 plus B2 times H.
Yeah, but how did you get that? Again, I will cut this triangle just to understand how the basic geometry works. It's so easy. Okay, now this I cut it and put it in here. See, you see what happens? This triangle, and then you have a parallelogram. This parallelogram is what you need. Okay. Otherwise, okay. So here, when you think about it, right? Let's okay, let's split it up into rather than doing that, let's do this. So now it becomes basically you cut it and put it in here, right? Let's say you cut that and put it in here and put it in here. Okay, so now when you think about it, right? Okay, here you have to add the triangle area with the rectangle area. Add this triangle. When you think about this, right, the height is always the height. Okay, so half for the triangle. Let's consider this is the triangle plus, take it as a parallelogram of the rectangle. Okay, I'll take it as a parallelogram because rectangle is a parallelogram as well. Okay, so if I take that half h, what is this, guys? This is entirely B2, right? In that, I'm going to subtract what? This is going to be B2 minus B1. So now, when you put that in, that is the area of the that's the area of the triangle. Now, B2 minus B1, this is the area of this triangle, plus parallelogram can be B1 times H. Now simplify this, half B2H minus half B1H plus B1H. These two are alike. Do you see it? So that becomes half B2H plus half B1H. This is how you arrived at the formula. Half H, you take it out. You have B1 and B2 inside. Does that make sense? Everything is a learning. That's fine. Okay, we'll grow more because when you finish learning your algebra and geometry, it becomes a lot easier. Tanisha, have you completed geometry, ma?
Not all, but some.
No, as a part of school. Oh, you split and do at school,
Because I have
correct?
AGS 1, 2,
Okay,
and 3.
okay.
So
I know. Yeah, I got it. I forgot. Okay. So now, let's consider this one. How about this? Can we try this one? Let's see this one. In the quadrilateral PEAR, let's see whether we can do this. PE is 21, EA is 20, AR is 15. I'm not drawing the way. AR is 15. And then AP, okay, wait. PE is 21, EA is 20, AR is 15, and RE is 25. AP, EA is 20, AR is 15, RE is 25, and AP, oh wow, AP is 29. Find the area of the quadrilateral. Do you think you can do this? Why don't you try?
is there like a picture that comes with this.
You want the picture with this? Okay.
Yeah.
I don't think it is in there, but I can check if I missed. No. Is that making your task difficult?
Yes.
Actually, no. Wait, it's a part of some old paper only. Let's see. EER. Quadrilateral, right? You can go ahead. You don't need to wait, but you can go ahead in the meantime. No, no, there is none coming with it. Yep. Think about, see, last week we did discuss Pythagorean triplets, right? Do you remember what is the Pythagorean triplet for 29? See, AP is 29. Do you remember what is the Pythagorean triplet for 29?
20, 21, 29.
Ah, does that give you a clue? Does that make sense? Good. Then why don't you solve? So basically PE is 21. PE is 21. EA is 20. Ah, okay. EA is 20. PE, 20, 21. PE 21. EA 20. AR is 15. AR is 15. AP is 29. Mm-hmm. You can draw your own. Did you get it? EA is 20. AR is 15. RE. RE is 25. Okay. You get it, guys? One is a right triangle. The other one you have to check. Did you get it? You don't need anything here, right? Let's see. How did you do, Tanisha? Did you get it? Shireen, did you? Any thoughts? Please pour in, guys. I'm okay. Oh, that's good. That's good, Tanisha. Do you want to explain?
My figure is slightly different.
Okay, I'll go ahead with it. You go ahead.
So I have PEAR. Do you want to draw it on the board?
You want to draw? Please draw. If you want me to draw, I'll draw.
Okay, I'll try drawing. Let's see.
You can annotate.
Yeah. Okay.
See, now the figure not given complicates the problem.
Yeah.
First, you need to understand what type of a figure it is. Okay. If I
Yeah.
just draw the actual figure, then it will never be easy for you to come up with it.
Yeah, I figured.
Yeah. So by see, the thing is they want you to see this. Okay, 21, 20, 29, 25. There is some right angle triangle hidden. Go ahead.
Yes.
Good one. That's a right trapezoid. Nice. Go ahead.
Okay, so we have P.
I can write it for you. P. Can I
Okay,
write E
I
here?
can't. Yeah. This is E, and then
Can I
A.
write A here?
Yes.
Mm-hmm.
R.
Good.
So this is right,
Mm-hmm.
and this is right.
Yeah. So what should be the sides? PE will be
So
21.
yeah, this is 20.
Mm-hmm.
This one here is 15 below it.
ER is 15, correct. Okay.
Yeah, and then RE we have 25.
RE we have 25. Okay.
And
then we have AP. AP
yeah.
29. Okay.
So we know this. We know that angle A is a right angle because 15 square plus 20 square does equal 25 square.
Mm-hmm.
We know that this is a right angle because 21, 20, and 29 are Pythagorean triple.
Mm-hmm.
Then we can draw here this line, subtract 15 from 21. So this is 6. And then we
But
find the area.
yeah, but should we really go with that? Can't we use the area of a trapezoid directly?
Yeah, or we can divide it into triangle and rectangle. Both ways work.
Perfect. So we can use the formula for a trapezoid area directly,
Yeah.
right? With these two as
Yeah.
the basis.
Yeah,
This
we
and
can
this
do
as
that.
the basis. This will be the height. Why that becomes the height directly? Because the base is perpendicular to the height. So that would be half times 20 times 21 plus 15, which is 360 square units.
Yeah.
Ashi and Sresht, are you following?
Yes.
Okay, good. This one is a complicated one. Let's see. I really want to do this, but hey, this one is an easy one. Okay. You've been pestering your mind, so I would really like to give this. Okay, let's see this one. How about this? There is a figure. Do you see the figure? Do you see the figure on the board?
Yeah.
Okay. Now, this is an easy problem. But you have to think differently. That's my only request. You have to think very differently. Okay. How about this? Think differently. It's very easy to crack. 3 identical triangles are put together to form a rectangle. Given that the length of the short side of the smaller rectangles is 5 feet. I don't want to mark it there. If I mark it there, you'll get the answer. I'll just wait. Shorter side, what does it say? Shorter side of the small rectangle is 5. Small rectangle is 5. 5 feet. Sorry, I put it as centimeters. Okay. Good job, Tanisha. Shahrin, very nice. Arna, check Arna. You're almost there. Mitra, nice. Mitra, be confident, Mitra. No question marks. You already got it correct. So, Arna, correct. What mistake did you make, ma? What made you? Oh, you thought it's a square? Okay, let's go ahead and quickly brief. Would anybody like to explain? Arna, would you like to explain?
So the shorter side of each of the rectangles is 5 feet,
Mm.
which means that for the short side of the giant rectangle, it's 5 plus 5, which is 10.
Mm-hmm.
And then for the longer side of the rectangle, it's 10 plus 5, which is 15.
Good job. So the rectangle sides become 15 and a 10. Does that make sense, guys? So 150 unit square. Okay, that was an easy one. Okay. Rather than pestering every time, I thought, okay, I'll give it to you one easy. How about, okay, how about, yeah, you can do these at home. Yeah, this one is a nice one. Would you want to try this one? This one is a nice one, a previous AMC8 problem. Okay. How about this? I want you to draw. Without drawing, you're not never going to get this. I want you to draw it out. See, some of the problems I'm skipping. I'll give it to you as homework anyway. There's one problem which I want you to have a square paper at home. Do it once, check, get the answer, bring it back next week. Okay, that I'll mark it in the homework for you. Meaning, there is one problem in the homework where I want you to take a square piece of paper, fold it into a rectangle, and then whatever folds they have given in the problem, I want you to fold it as they have given with the square paper. Then mark the sides. What are the measurements of each side? Mark on the square paper physically. Find out the answer. I'm not going to give you the answer for that one problem. Find out the answer and bring it back next week. We'll discuss next week for that one problem. Time goes off.
So we can draw this one out, right?
Yes, yes.
Okay.
You have to draw, ma, otherwise you won't get it.
Yeah.
Auntie, I sent you an answer.
Wow. Check once more. I know what you missed, Mitra. Can you check once more? Or am I
Yeah, I realized.
You realize, or I am calculating it wrongly?
No, I made a mistake.
Yeah, I think so. I think so. Check. It's a simple mistake. Looks like you understood it. Correct, ma. Tanisha, correct. Tanisha, correct. This is also a previous AMC8 problem, guys, based on only the concepts that we studied. What was the problem? I'll do the problem on the board, guys, for everybody. But what is it? Arna, can you correct your answer and resend? So this one, guys, I wanted you to draw. The others can work out the other one. See, minus 3 comma 0, 2 comma 0, 5 comma 4, and then 0 comma 4. These are the midpoints of 0, 4. What is this? 5, 4. Yeah, this is 5, 4. So basically, these are the midpoints of the rectangle. So you will have to draw the rectangle, then only it becomes easy. You will have to draw the rectangle. See, now things become so easy. When you draw this rectangle like this, right? These are the midpoints of the rectangle. So what was asked? What is the area of the rectangle? Correct? What is the area of the rectangle? How did you do? Who wants to say? Hey, Arna, did you correct it?
I think I did it wrong. I don't get it.
Yeah, but there's a minor mistake, that's all. Do you want to check that? Okay, Tanisha, you want to go ahead and explain?
Okay.
Mm.
I combined the midpoints to form a parallelogram.
Good, nice. Let me do. There are multiple ways of doing this. Okay, well, let me, ma. 1 minute, ma. You combined it to a parallelogram. Okay, then.
Then, so the area of whatever figure the midpoints form, for a rectangle, that is half the area of the actual rectangle. So we know the length here is 5, and the height would be 4.
This is 5. Yeah, 5. Height is 4. Correct.
Yes. So then 5 times 4 is 20, and 20 times 2 is 40.
20 square units for the parallelogram.
Yeah.
Times 2 becomes the rectangle. 40 square units for the. Any questions, guys? This is the rectangle area.
Why is the parallelogram half of the rectangle?
Because these are midpoints.
Oh, okay.
Good question though. How about this one? Next one. It's a good one. This is as well a previous AMC8 problem. Two congruent squares A, B, C, D. Two congruent squares and PQRS have side length 15. They overlap to form the 15 by 25 rectangle AQRD. So what is this? Okay, I'll leave it to you because they're asking for the percentage, right? So how will you do percentage? What percent of the area of the rectangle AQRD is shaded? So shaded area divided by the area of the rectangle, which in a sense it's pretty easy. This one is. Percentage should be expressed as for 100%. So it should be expressed as a percentage. You might get a fraction, but you have to be careful to make it into a percentage and tell the answer. Quadrilaterals are a little easier than similar triangles and congruent triangles is my humble thought. Arna, did you understand, Matt? Did you understand the last problem?
Yeah, I got it.
This one is not a hard one, guys. Try and I'll help you. Sresh, can we try together? Or
Yeah.
Ashi, can we try together? Okay, go ahead, Sresh. Okay, I'll help you. Okay, you're going to figure it out. See, there were two congruent squares that overlapped. If it would have been two congruent squares, then the side length should have been 30, meaning if they had been positioned like this, equally, right? This is 15, this is 15. But due to the overlap, it became 25. So how much is this?
5.
5, you got it. So how much is this?
15.
Yep, now you know. Find out the percentage. 5 by 15 is the shaded area. So what percentage they are asking? Shaded area divided by the total total AQRD area. AQRD area is very clear, 25 by 15. Right? So it's 1 by 5. Please, 1 by 5 is 20%. Good. You corrected it. Correct. Good job, Tanisha. Can I move on? Okay. Dia, are you following, ma?
Yeah.
Okay. Okay, now for the circle areas, let's see. Circle whatever we left last week, right? Was a ton actually. I'm skipping some of the questions I wanted to do in class. I can't. Okay. Hey guys, you know about area of sector and length of the arc? This is concepts. This is not yet any problem. Okay. For any circle, right? Let's see. For any circle, what is this, guys? What is this area called? What is this area called?
The sector.
Sector. Good job. Do you know how to find the area of the sector? Okay, I'll tell you. You don't need to memorize anything. Okay, please don't memorize areas of sectors. Okay, Tanisha, have you done the area of a sector and area of length of the arc?
No, I haven't done that.
Okay, so for the area of the sector, right, what you can do, what is the angle around a point?
Three.
What is a 360? Good job, 360. So let's say this is x. Okay, the degree measure of this is x. So for the area of the sector, right, can I make a proportion ratio? Can I make a ratio between area of the sector divided by area of the circle? Can I do that? So area of the sector, that's what we need, right? Divided by area of the circle. Let's say the radius of the circle is r. Now see, this is all area, right? Now this angle is x, correct? This angle is x. The sector is making angle x. So what should this be? Area of the circle, what should that be making? Area of the circle is making a 360 degrees. Makes sense, guys? So area of the sector. So you're creating two ratios. What two ratios are you creating? One is the area of the sector to the total area of the circle. That is one ratio, area ratio. Other one is the sector is formed by this angle x divided by the whole circle is making a 360. So x by 360 will be equal to the area of the sector divided by pi r square. So area of the sector will be equal to x by 360 times pi r square, where x is the angle of the, this is the sector, right? Sector makes an angle, central angle of x, and then r is the radius of the circle. Similarly, how about this? Let's say you want the length of the arc. What ratios can I make? Very similar. Length of the arc can be compared with what? Meaning the ratio with what? See, like area of the sector divided by the area of the circle. Like length of the arc can be compared with what? Yes, Mamitra.
2 pi r.
Which one?
2 pi r. The
2 pi r, circumference. Good job. Circumference of the circle. Circumference of the circle. So length of the arc. Let's say length of the arc by 2 pi r will be equal to, these two formulas you need to know. Okay. Again, a by 360 or x by 360. Here I have taken it as x, right? Does it make sense, guys? So length of the arc will be equal to x by 360 times 2 pi r. Since you're considering the length of the arc, you'll multiply that angle ratio with the circumference. Since you consider the area of the sector, you'll multiply with pi r squared. Will you remember this, guys? You're just making two ratios. When you equate two ratios, what it is? It's a proportion. So you're creating proportions to find out the area of the sector and the length of the arc. Ashi, Am I reaching, meaning you're okay? Okay.
I have a question, ma'am.
Yeah, go ahead.
Why are we taking x like that?
Oh, this angle. Okay. This angle, right? This is partial. This is full angle 360, correct?
Yeah.
So this angle is part of the 360. This sector is a part of the sector area is a part of the area of the circle. Am I making sense?
Yes.
So they are proportional, meaning for x degree, it can create an area of the sector. Okay. Then for 360 degree, it can create pi r square. Does that make sense?
Yes.
So two ratios, your two ratios, meaning angle by angle, area by area. Or you can write pi r square area that is created by the 360 degree rotation, right? That you can equate it to area of sector divided by the angle that the sector makes, x. Make sense? The,
I have a
go
question.
ahead. Yeah, please.
The length of the arc, so the length of the arc is the x over 360 times pi d?
2 pi r, correct.
2 pi r. Okay, got it.
Correct. Pi or okay. As you say, I can take it as pi d as well. 2r becomes d. Make sense, ma? Okay, now we'll solve at least one problem on that, guys.
Can you show that again?
Oh, I'm sorry. 1 minute. I'll go back. How do I go back? Yes. Yeah, there are, okay. I'll do one thing. Then today, this week, I'll give you only problems on some of the problems you can still solve. Hey, did we discuss chords and tangents to circle? We did, right? I have to go back and check. Did we do chords? Week 1, did we do chords? Shahrin, you're nodding or what?
We did a little bit.
We did a little bit. Okay, let's see. Okay, anyway, I will not give you problems on that, I feel, because I don't feel comfortable. How about this? Okay, this one is an AMC problem. Let's see. Shall we try this one? We'll try this one. Rectangle ABCD is inscribed in a semicircle with diameter FE. Okay, as shown in the figure. DA is 16, FD equal to AE equal to 9. What is the area ABCD? Done, guys? How are you thinking about it? Can one of you tell me? Rectangle ABCD is inscribed in a semicircle. Okay. Now I know this is 8, this is 8, but I do not know what is this. What can I do about it? But this is an application problem from 7th grade. Try. What can you apply? See, the thing is, the difficulty is only to apply what we have learned. Can you see right angles there and here? When you see right angles there and here, what can you do? Unless you find this, you are never going to solve this problem, right? How to find it? Mitra, any thoughts? Mitra? Yes, Sresh. I'm so happy you have a thought. Go ahead. Whether it is wrong or right, just say.
We can find the radius also if
Very nice. How can you find the radius?
9 plus 16 plus 9 divided by 2
9 plus 60. Yes. So 9 plus 16?
plus 9 divided by 2, which would be 17.
Correct. Mm-hmm.
And
Now, good. You're all there. You found out the radius. Very nice. Then,
I have a question.
Yama.
So then, if that's the radius, then if you connect the midpoint of like DA to B,
Very nice. Very
then
nice.
it forms a right triangle.
Yes, nice.
And
Yes,
you know
Tanisha, I think
this-
answer is right. Mm.
And you know that that is 17.
Mm-hmm.
And
So
then
this
so
is
then we know
8.
that that's
We know that 17. What is this?
15.
15. So 15 times 16 is 240 square units. Did you all get it, guys? Okay. We did only quadrilaterals, okay? Circles, meaning I won't say we touched so much of what I wanted, okay? That's okay. I'll give you questions on quadrilaterals plus circles, what you can do using the length, arc, and all that stuff. Area of the sector, all that stuff. There are some difficult questions as well. Okay, and for one of the questions, I really want you to have a square piece of paper, fold it into a rectangle, and then fold the diagonals together, diagonal endpoints, vertices together, and literally do it, then complete each side values. Okay, take a pencil, mark, and then find out and come back. For that, I'm not going to give you the I'll give you the answers. Okay. In the meantime, next week before you come back, right? Why don't you analyze Pascal's triangle and come back? Can you analyze what is Pascal's triangle and come back? Because that's a part of combinatorics. Everything if we discuss, right, it is taking weeks and weeks. So why don't you analyze Pascal's triangle and come back? You all know basics of permutation combination, right? So go ahead and see what is Pascal's triangle, how it is formed. Okay. So you have two homework, Pascal's triangle. Do the one problem. You're going to fold and see, and then I'm going to give you problems on whatever we have covered with quadrilaterals. Any questions, guys? Any questions? Okay, guys. See you all next week.
I have a question.
Yes, ma'am.
How did you get 15 as the side length of the rectangle? I didn't get it.
No problem. Okay, let me finish. Yeah, guys, if you don't have any questions, you can log off. 15 as the side length of a triangle. 1 minute, wait, I switched off my pad. Okay, here, 8, 8, right? This radius is 15, right, ma? So now when you connect this point and this point, that's the radius only, right? Now this becomes a right triangle, right? So 15 square minus 8 square is this. Did you get it?
Ma'am, the radius is 17.
I'm sorry, 17, no, 17. 17, 17, then 17 square minus 8 square. 17 square minus 8 square will give you x square. So that x times 16 is the area of the shaded figure. Make sense?
Yeah, thank you.
Okay. Good catch, Shreshth.
Thank you.
Yes,
Bye.
ma. Bye, ma.
Ma'am, I have a question.
Yes, ma.
Could you go back to the picture?
Go back to the picture. 1 second. I am making somebody wait at home. Okay. See this one?
Yeah, how do you get 8 of like as the
No, I like your way. Don't worry about it. Your way, I liked it. Okay. I did it as 8, 8. Okay. Do it like this. Okay. 16 plus 9 plus 9 is what? Divide by 2.
But
I like your
ma'am,
way.
ma'am, I have one question.
Mm.
Here it is not showing ki this whatever where is center and this
Correct. So you're
rectangle is in center. It is dividing half. It is not anywhere. It is not showing, right? Ki it is
yes,
on the
but it is symmetrical, right? 9, 9. This is a square.
That's
But okay, but said that right. But I like Shresh's way of doing. This is the diameter that you accept, right?
yeah. No. My question is,
Uh,
how can we define ki this midpoint is the midpoint of the whatever
Semicircle.
squares midpoint also?
Ilma, you're not defining it at all, right? 18 plus 16 divided by 2 is your radius, correct?
Yeah.
Radius always meets at the center, meaning from center to this is the radius, right?
Yeah. No, radius, I understand radius.
This
but
is radius, right?
yeah, that is also correct. But Hindi, how can like कैसे हमको पता है कि this square जो है वो उसका जो DA का mid point center circle का center है? How can we assume that? How can we assume that DA midpoint is the center of the circle?
Oh, because it's symmetrical only, right? This side is 9, this side
Symmetrical.
is 9, this is
So that-
16. It's a square. It's a square.
But nowhere it is written, right?
That
It is on the center, like I don't know.
Yeah, I see what you're saying. Okay, you're
Yeah.
going to wait a minute, okay? I have somebody at the door.
Yeah.
No, you have to wait for 10-15 minutes because I asked him to come at 8:30.
Yeah.
He's waiting from 8:50.
Yeah.
Give a
It's
minute. I'll
Huh.
go give it and come. I have some prices for a kid, okay?
Oh, okay. No problem.
He's outside. Sorry, ma. I'm here back.
It's okay.
Is your mom there?
Yeah, she's coming. She just went to the
Wait.
restroom.
Are you there?
Yeah.
Hey, I'm really sorry. Okay. But this is symmetric, right, mom?
Yeah, now I get it, but
Still,
it's
you're
not.
not. Other see, this is symmetric, right? 9,
Yes.
9.
Yeah. But
Go
the-
ahead.
yeah, the doubt is how we can assume it will cut the center of the circle will be on the middle of this DA. We can assume, but
See, okay. This is the radius, right? Meaning only to the center you can connect the radius. Okay. Now you know the radius. This radius is 17. This is 17, right? 17 minus 9 is 8, right?
yeah.
No. Did you get it?
Yeah, by
Amma, no, ma. See. Okay. By 9 plus 9 plus 16 divide by 2. You got it? This is 18 plus 16 is what? 18 plus 16 is 18 and
34.
yeah, 30.
50.
17, correct.
Seven,
So
yes.
somewhere 17 is there. 17 is the radius. Okay, let me have some center here. Okay,
Yeah.
doesn't have to be. Now 17. Okay, this is 17. This is 17. So definitely this is the midpoint, correct?
Yeah.
This can't be, meaning this can't be 19 and this can't be 17. Both are 17, correct? So from that 17, subtract the 9, you get the 8.
8. Yeah, that I know. But yeah, now, yeah, because this is 9 and this is 9. So this we can assume as a center.
8. And 9 and 8 here, 9 and 8 here. See, why this is the center means 17 is the radius, right? That itself puts this is the center.
Yes.
Okay. Any other questions?
No.
Okay.
Sorry to bother you.
No worries. But he is grasping well. Only thing is, I really honestly feel most of the kids in this class are not exposed to any of these topics.
Oh, yeah.
See, that's I don't know. That's the way.
Maybe they are like, yeah, arches and all, he also didn't. Today I will teach him this arch and sector. But
I see.
rhombus and all, he is used to.